Let's begin today's session, today's problem we can say. So I think 8 problem was going on. Right. 8 problem चालू होता आपलं. What is that 8 problem over there? And flywheel in the form of disc is rotating about an axis passing through its center. So flywheel, that means a wheel is there. So wheel somehow extend, we can say that it is a what in nature? It is a, we can say that it is like a it is something like that. We can say that something like a disc. If flywheel means flywheel, that means we can say it is like a disc, right? So that disc or that flywheel, which is we can say that rotating about an axis passing through its center and the perpendicular to the plane loses energy. So energy is equal to, or loss of energy is equal to loss of energy will be is equal to 100 joule. Loss, that means you can take a negative because it is a loss, right? 100 joule is the loss of energy when it is a slowing down. So initial frequency is given, that is 60 rpm, 60 rpm revolution or the rotation per minute. Slowing down from 60 to we can say that 30, its speed is get decreases. That's a speed काय झाला म्हणतात आपण decrease झालाय from we can say that 30 from 60 rpm to 30 rpm. So while decreasing speed, it loses its energy by 100 joule, right? And they ask you to find out the moment of inertia about the same axis and change in the angular momentum. So they ask you to find out what is the moment of inertia of that particular disk, and we can say the change in angular momentum. Change in angular momentum, that means they ask you to find out final angular momentum minus initial angular momentum. These are the, we can say that quantity. They ask you to find out final angular momentum minus initial angular momentum, right? Initial, we can say that angular momentum, initial angular. This is the second quantity they ask you to find out. So first quantity is nothing but I. I is nothing but we can say that moment of inertia. So moment of inertia of disk will be is equal to moment of inertia of disk will be is equal to how much? Mr square by 2. Moment of inertia of disk is equal to mr square by 2. But we don't have a, we can say that mass, it is not given. Radius of that disk is not given, but loss of energy is given. And find initial angular frequency and final angular frequency. Frequencies are given. So loss of energy, that means, and loss of energy is equal to loss of energy will be is equal to, we can say that will be is equal to change in kinetic energy. Loss of energy. Why that loss is supposed to happen? Due to change in a speed or change in angular velocity. So change in kinetic energy. So how to write down change in kinetic energy? That is final kinetic energy or kinetic energy of a final kinetic energy minus initial kinetic energy. So something is, we can say that like that we have. So final kinetic energy, initial kinetic energy. So kinetic energy final, that will be is equal to 1 by 2 I omega final square minus 1 by 2 I omega initial square. But instead of omega final, omega initial, n1, n2 is given. We knew that omega final will be equal to 2 pi n2. Omega initial will be equal to 2 pi n1. Because n1 is the initial frequency, that's the reason why initial angular velocity. N2 is the final frequency, and that's the reason why in the formula I place n2. So that will become a 2 pi n2 will become omega final. So by placing the value of omega final, omega initial in that particular formula, right? Here we have loss of kinetic energy, that is equal to 100 joule. So we'll get the value something like that. It's quite easy, right? So second quantity I'll solve over here. First quantity I'll solve over here. That is equal to I. So minus of 100 joule will be is equal to 1 by 2 I. I'm going to take a common. So in a bracket, omega final square, that is 2 pi, omega final value of 2 pi n2 bracket square minus omega initial square, that is 2 pi, we can say that n1 whole bracket square, because 1 by 2 I, if I take a common from here, what will remain? Omega final. Omega final, the value of omega final I just place over here. Minus omega initial. Here, if I take a 1 by 2 I common, what will remain here? Omega initial and omega final. So the subtraction of omega final minus, that means omega final and omega initial. Subtraction of omega final, omega initial, right? So 1 by 2, 1 by 2 minus of 100 of joule as it is. I that we don't know, that we wanted to calculate. 2 pi, keep a 2 pi as it is, right? N2 is equal to what? 30 rpm. Keep in rpm 30, right? It's bracket square minus 2 pi as it is, right? N1, instead of N1, what is, you can write down 60 multiplied by 60 whole bracket square, right? So by simplifying, you will get the value of I. By simplifying, we can say that you will get the value of I. You just note it down and then we'll move forward, right? Right? You can place the value of that particular 30, 60, you will get this simple. Okay, I'll simplify over here. What will remain over there? I'm keeping this minus 100 into 2, that is equal to minus 200. That will become into I in bracket 2 square 4 pi square 30 square, that is 900, right? Minus 2 pi square, that is, we can say that 4 pi square 60 square 3600, 36 into 3600. By simplification, you will get I, and the value of I will be is equals to value of I by solving this particular problem. Value of I in this particular problem, that is 6.753 kg meter square. 6.753 kg meter square. So this is nothing but we can say that solution of this particular question. Quite easy. By loss of kinetic energy, loss of energy is equal to change in kinetic energy. So I place the value everything. I place the value of omega final, omega initial over here. By keeping a 1 by 2, take a I took a common, and by just putting the values by simplification, keep I over here, take whole bracket to this side, divide that factor, you will get the answer, right? So something is like this. This is now about a, we can say that, moment of inertia of that particular body, right? Now we wanted to find out change in angular momentum. So change in angular momentum will be is equal to delta L if initial angular momentum will be is equal to initial angular momentum will be is equal to I omega final, because angular momentum is nothing but a product of moment of inertia and angular velocity, right? So that's the reason why initial angular momentum will be is equal to I omega, not final, I omega initial, sorry, it is the initial one. Final angular momentum will be is equal to final angular momentum will be is equal to I into omega final, means in moment of inertia and angular frequency, right? Why I took a common why I took a same moment of inertia, because body is not going to change, so that's the reason why moment of inertia will be same. So change in angular momentum will be equal to final angular momentum. Okay, let's denote final angular momentum by L2, initial angular momentum by L1. So change in angular momentum, final minus initial angular momentum. Final minus initial angular momentum. So final angular momentum will be equal to I omega final, right? Minus initial angular momentum, that will be equal to I omega initial, right? So I omega final, I we are aware of that. Okay, omega final minus omega initial. Take a I common, right? So delta L will be equal. What is I? 6.753. That you already got. 6.753. By calculation, you will get that value. To omega final 2 pi n2, right? 2 pi into n2. What is n2? N2 is nothing but a 30 into 30 minus omega initial 2 pi n1. 2 pi into n1. N1 is equal to how much? N1 is nothing but how much? That is equal to 60, right? So By simplifying this, you'll get the answer. Means that will become a -1, but the minus in the sense why? Because it's the loss of we can say that energy. Due to that reason, this delta will become a minus because 2 pi 13 this, so 6.75. Why it is so? I said that minus because 30 into 2 60 pi minus 60 into 2 120 pi, right? So 60 minus 120, that is minus 60, right? 6.753 multiplied by minus of 65. This is not subtraction, this is a multiplication. So minus that answer will become minus, and the multiplication of 6.753 and into 60 pi. So loss it is there, so that's the reason why this quantity will be also negative. This quantity will be negative. So negative sign will get cancelled. You will get a delta L positive. And by multiplication, if you just solve this particular problem, so delta L become 21.21 or 21.22, something like that you will get, right? So this is nothing but we can say that answer of that particular question, that is kg meter square per second, right? Still, if you have any doubt, you can send me that in a chat box, right? Next problem will be like this. There are two wheels of moment of inertia. Here we have a two wheels. For example, something like that. We have a two wheels. This is first wheel, right? And it is just attached to the second one by a weightless shaft. Means the mass of the shaft is very, very less, right? Something like this. Something like this. Here, like this, we have a picture, right? So, something like this. What it is there? Two wheels of moment of inertia, 4 kg meter square. So both have a same moment of inertia. That is equal to, we can say that 4 kg meter square. The moment of inertia of the both body is same, and rotate side by side. Side by side means they are not one after another. They are not like a two wheelers. The two wheelers wheels of the two wheelers, they are supposed to, we can say that they are rotating one after another. Means front wheel is front and rear wheel is at the back, right? So something like they are not side by side, but side by side wheel, that means the wheels of a four wheelers. Four wheelers are they rotating side by side, right? So they are rotating side by side at the rate of 120 revolution per minute and 240 revolution per minute. So first we'll say, suppose to say it is rotating 120 revolution per minute, or you can take a first this is 240 revolution per minute, and second one you can take a 120 revolution per minute. You know, to get the addition, subtraction, positive. So find first I'm taking 240 and second I'm taking 120. So that is nothing is wrong in that by taking any values of any particular wheel, right? Respectively in opposite direction. So one, if it is moving in a forward direction, one another should rotate in a opposite direction. That means their moment of inertia will get reverse. Their values will get reverse. If one is a positive one, another will be a negative, right? So that is the case. That is very important for the direction. One, if one moment of inertia is a positive, second should be, we can say that, negative moment of inertia, right? So that's the reason why they give you opposite direction. In both, if now both wheels are coupled by means of weightless shaft, so that both wheels now rotate in common angular velocity. Now this is the first case. In a second case, both wheel are now they are rotating. Both wheel are now that they are rotating in a same direction. दोन्ही wheel आता काय होता है, सेम डायरेक्शन ला काय म्हणतात आपण, रोटेट होत आहे. म्हणजे दोघांचे मोमेंट ऑफ इनर्शिया आता काय म्हणतात आपण, सेम आहेत. सॉरी, दोघांचे मोमेंट ऑफ इनर्शिया आता तुम्हाला कॅल्क्युलेट करायचे आहे. इथला मोमेंट ऑफ इनर्शिया मी आय डॅश म्हणला, इथला मोमेंट ऑफ इनर्शिया आय डॅश म्हणला. दोघं सेम डायरेक्शनला म्हणून दोघे काय राहतील, पॉझिटिव्ह घेता येईल, राईट? इफ now both wheels are coupled by means of weightless shaft, so that both the wheels now rotate with the common angular velocity. दोघांची angular velocity same असेल. दोघांची angular velocity काय नसतं पण सेम असेल. तर find the new speed of rotation. Find the new speed of rotation. दोघांची नवीन ती फ्रिक्वेन्सी आपल्याला काय करायची आहे, ते शोधायची. कारण आन्सर आरपीएम मध्ये दिले. आन्सर आरपीएम मध्ये दिले म्हणजे काय करायची, यांची आता फ्रिक्वेन्सी शोधायची. दोघे दोन्ही सिस्टम सेम आहे. दोघांचा मोमेंट ऑफ इनर्शिया काय म्हणतात आपण त्या पद्धतीने दिलेला आहे, राईट. तो ऑलरेडी आपल्याला इथे मेन्शन आहे. तर आपल्याला इथे काय करायचं, लॉ ऑफ कॉन्झर्वेशन ऑफ अँग्युलर मोमेंटम यूज करायचं. लॉ ऑफ कॉन्झर्वेशन ऑफ अँग्युलर मोमेंटम यूज करायचं. अँग्युलर मोमेंटम. So what do you mean by law of conservation of angular momentum? That gives you initial angular momentum of system. Initial angular momentum of system, that will be is equals to final angular momentum of system. Final angular momentum of system. Final angular, we can say that momentum of system. So what is the final angular, initial angular momentum of system? Angular momentum of the first body. Angular momentum of the first body, its moment of inertia and its velocity. That is nothing but a, say, its angular velocity. I am going to take omega 1. Angular velocity here omega 1. Angular velocity here it is say omega 2. In the second case, angular velocity of both will are same and they are attached by a wheel. Right. Now, initial angular momentum of the system. System is two, both. So angular momentum of the system, that means angular momentum of the first body, that is the product of moment of inertia and angular velocity. Now next, system's angular momentum शोधायचं, म्हणजे पहिल्या बॉडीचा angular momentum शोधावा लागेल, दुसऱ्या बॉडीचा angular momentum काय म्हणतात आपल्याला शोधावं लागेल. मग आता पहिल्या बॉडीचा angular momentum आपण सांगितलं, that is I into omega 1. दुसऱ्या बॉडीचा angular momentum I into omega 2. Okay, that will be is equals to final angular momentum of system. System मध्ये कोणी दोन व्हील, मग दोघांचे मोमेंट ऑफ इनर्शिया, दोघांचे मोमेंट ऑफ इनर्शिया म्हणजे दोघांबरोबर दोघांचा मोमेंट ऑफ इनर्शिया दुसऱ्या बॉडीचा त्याचा मोमेंट ऑफ इनर्शियाची ऍडिशन. सो आय डॅश बॉडीचं सेम आहे त्यामुळे मोमेंट ऑफ इनर्शिया सुद्धा काय राहील, सेम राहील, प्रिव्हियस इतकाच राहील. आय ओमेगा प्लस दुसऱ्या बॉडीचा मोमेंट ऑफ इनर्शिया आय ओमेगा प्लस आय ओमेगा 2 आय ओमेगा. इथं जर समजा आपण I1 जर कॉमन जर घेतलं, I1 I जर कॉमन घेतलं तर काय राहील, ओमेगा 1, that is omega 1 plus omega 2. So what cancelled over here? I will get cancelled. त्याची व्हॅल्यू त्याची गरजही पडत नाही आपल्याला. मग आता ओमेगा 1 काय 2 पाय n1 प्लस ओमेगा 2 काय राहील. ओके, आता सगळ्यात महत्त्वाचं म्हणजे एक पॉझिटिव्ह डायरेक्शनला जाते, दुसरी निगेटिव्ह, म्हणजे एक फॉरवर्ड डायरेक्शनला रोटेट, दुसरा बॅकवर्ड डायरेक्शनला. मग दुसऱ्याची वेलोसिटी अँग्युलर वेलोसिटी घेताना काय घ्या, ओमेगा घ्या किंवा मोमेंटम घ्या, काय घ्या मायनस घ्या. मायनस ओमेगा 2 ची किंमत काय 2 पाय n2 will be is equals to twice of omega. ओमेगा इथे काय येईल मग, that is equals to 2 पाय n. या ओमेगा साठी काय लिहितील आपल्याला, this omega will be is equals to 2 पाय n. This omega will be equals to 2 pi n, and 2 pi n 2 pi n 2 times of 2 pi n. आता इथला 2 pi जर कॉमन जर घेतला, इथला 2 pi जर कॉमन घेतला तर राहील n1 minus n2. बरोबर. इथे जर समजा आपण 2 pi जर कॉमन जर घेतला, इथे काय राहील ब्रॅकेट मध्ये, हा 2 pi जर कॉमन घेतला तर काय राहील 2n राहील. तर 2 pi कॉमन घेतला ब्रॅकेट मध्ये राहिला फक्त twice n. बरोबर. हा 2 pi कॅन्सल करा, राहिला का n1 minus n2 is equals to twice n. n1 minus n2 will be is equals to twice of n, right? So n1 equal to 240. n1 will be is equals to 240 minus n2 will be is equals to 120. n2 will be is equals to 120. So twice n will be like this. So 240 minus 120, 120, and n will be is equals to 2 will get divided to 120. So 120 divided by 2, that will be is equals to 60 rpm. So this is nothing but a solution of this particular problem, right? Just note it down and then we'll move forward. This is the last problem that we wanted to discuss. Okay, थांबूयात आजच्या सेशनला, थांबूयात. तुम्ही हा व्हिडिओ